Chemistry 2 Advanced Level Chemistry Preparation for Form 6 Examinations 2025. My name is Ramadan Siramdungu from St. Joseph University. So I invite you for the model questions and the answers for Chemistry Paper 2. Here there are 6 questions which covers the topics of two-component chemical kinetics, electrochemistry, acids, bases, and the salts, and the other topics. Now, question number 1 is about two-component liquids, and the question says, question number 1A, would you expect the mixture of pentane and hexane, Roman 2, propane, 1 oil, and the water to show deviation from Rath's law? So Rath's law, we have 2 deviations, positive deviation and a negative deviation. So the question is, would you expect a mixture of Roman 1, pentane, and the hexane to show deviation from Rath's law? The answer is no, because no, pentane and the hexane. And the hexane do not show negative deviation from Rath's law. The question 2, that is Roman 2, pentane 1 and water. Pentane 1, oil, and water. So these 2 show positive deviation because of formation of hydrogen bonding. So hydrogen bonding, which will be formed between pentane 1 oil and water, is the one which makes this mixture to show positive deviation from Rath's law. Question number 1B. Petrol and water are immiscible liquids. You may assume that petrol is made of hydrocarbon octane. So petrol is assumed to be octane. So the main component is octane, and water are immiscible liquids. So it means that they cannot form a clear solution. They form layers. Now the question is, petrol and water are immiscible. You may assume that petrol is made of the hydrocarbon octane. 1. What type of intermolecular bonding holds the octane molecules together? Octane molecules are held by van der Waals forces. While water is held by hydrogen bonding. So octane are held by van der Waals intermolecular forces. Roman 2, what type of intermolecular bonding holds the water molecules? So there is water. The intermolecular force or bonding holding water molecules is hydrogen bonding. Roman 3, compare the strength of bonds between 2 octane molecules, 2 water molecules, a water molecule and an octane molecules. So if we compare these 2, you find that the strongest force, intermolecular force of attraction, is between water and the water molecules, followed by octane and the octane molecules, and then the last one is water and the octane molecules. So this is the order of the intermolecular force of attraction existing between water molecules as well as octane molecules. Then 4, why the enthalpy of mixing for these 2 liquids very positive? Why the enthalpy of mixing these 2 liquids. So it means during mixing of water and the petrol, why the process is endothermic or is exothermic. This is because during mixing, so the energy is required to break strong bonds or strong force of attraction. So strong forces, as we have mentioned them, then you have to, the energy is a very positive, or it means that the strong force of attraction has to be broken between these molecules. Then question number 1 is C. Question number 1 is C. Question number 1 is C. It says a mixture of acetone and carbon disulfide shows a positive deviation from Rod's law. Carbon disulfide and acetone, CH3, CO, CH3. So the two show positive deviation from Rod's law. Positive deviation from Rod's law. Now, their vapor pressures are 0.39 atmosphere and 0.23 atmosphere respectively. So the vapor pressure of acetone is 0.39 atmosphere, and the vapor pressure of carbon disulfide is 0.23 atmosphere, and 3 atmosphere. Now, at 298 Kelvin, if a mixture of 0.2 mole as carbon disulfide, if 0.2 mole and 0.8 mole acetone, then a mixture of 0.2 mole carbon disulfide and 0.8 mole acetone were made. What will be the vapor pressure of the mixture if it were idle? How will this value compare with the true vapor pressure? Now, what is the vapor pressure if the two liquids are mixed together? So the vapor pressure of each component, vapor pressure of carbon disulfide is equal to number of moles, which is 2 mole times its pressure, which is 0.23, then this is the atmosphere. So this gives you 0.46. Then this gives us the pressure is so here is 0 for carbon disulfide. Here is 3. Then we take 0. Here we get 0.46, and atmospheres. While here, if you multiply, then you will get 0.39. Then times 0.8. This you will get the answer. So this is how to calculate it. The total pressure is less than the true pressure because these two liquids, once they are mixed, they form positive, or they deviate positively from Rod's law. So the total pressure is less than the expected or the true vapor pressure. Now question number 1D. Part D says a solution contains 2 grams of iodine dissolved in 20 ml of potassium iodide solution. If we shake the solution with 20 ml of organic solvent, how much iodine will be transferred into the organic solvent? Kd between organic solvent and the water is 85 at room temperature. Now here we have 2 grams of iodine dissolved in 20 milliliters of potassium iodide solution. If we shake this solution with 20 ml of organic solvent, how much iodine will be transferred to organic solvent. So here we have this is a solution containing 2 grams of iodine, but this is the aqueous solution. Then you add, here is 20 mils, then you add 20 mils of organic solvent, then you shake. After shaking, then the two will form layers, but there will be an equilibrium of this of iodine. Some of iodine will dissolve in the organic layer, and another one will dissolve in water. This is the aqueous layer or water layer, and this is the organic layer. Now the question is, how much iodine will be transferred to organic layer if the KD between organic layer and the water or aqueous layer is equal to 85. So here we apply the distribution formula. That is the concentration of iodine in the organic layer divided by concentration of iodine in water layer. So let the volume or the mass of iodine in organic layer be, so let it X grams of iodine be transferred to organic layer. So it means what remain in the water layer is 2 minus X of iodine. This will remain in the aqueous layer. So KD is equal to X over 20 mils divided by 2 minus X over 20. This is equal to 85. So we take X over 20 times 20 divided by 2, X is equal to 85. So when you calculate, then you will get 1.98 grams. So this is the amount of iodine transferred to organic layer. That is question number 1. Now we go to question number 2. Question number 2A. Now the question is about chemical kinetics as well as electrochemistry. Now the question is, why does the rate of chemical reaction increase on addition of a catalyst? Why the rate of chemical reaction increase on addition of catalyst? The role played by catalyst is to find. So the rate of reaction increase because addition of catalyst finds or it takes cause the reaction to takes the pathway or route with the minimum activation energy. Minimum activation energy. So when a catalyst is added to any reaction, it will change the pathway or route taken by that particular reaction, but it will find the pathway or create the mechanism which involve lower activation energy, because activation energy is like a barrier. It's a barrier that prevents a chemical reaction to occur. Once the reaction overcomes the activation energy, then the reaction occurs. That is why we say the activation energy is the minimum energy required to initiate the reaction. So by adding catalyst, the reaction will find the way or the route with the minimum activation energy. So it is not proper to say that the catalyst lowers the activation energy. Instead, it finds the route with the minimum activation energy. So that was the question number 2, A, Roman 1. Now Roman 2 says, will a given reaction have the same rate law for both a catalyzed and an uncatalyzed reaction? No, it is not true, because once a catalyst is added, the chemical reaction will create a new mechanism, and each mechanism has its own rate law. So the rate law will be different. So there will be different rate laws, because each mechanism has its own rate law. Mechanism has its own rate law. So whenever catalyst is added, then a new mechanism will be created. As a result, new rate law will be experienced. Then Roman 3, explain why temperature affects the rate constant. Why temperature affects the rate constant. Why they affects the rate constant. Now this it depends on type of reaction. Whether the reaction is exo or endothermic reaction. Now if the reaction is endothermic reaction. For endothermic reaction, increase in the temperature favor for the reaction. As a result, rate constant will increase. So rate constant will increase. More products will be formed as a result. Then for exothermic is a different case. Exothermic, then rate constant will decrease if we increase the temperature. If we increase the temperature. So that is question number 2A. Question number 2B says, for this reaction, for this hypothetical reaction, that is B plus A changes to C plus D. Now the question is the reaction A plus 2B to form C and D is run 3 times in the first run. So in the second run, the initial concentration of A is doubled that in the first run, and the initial rate of reaction is doubled that of the first run. In the third run, the initial concentration of each reactant is doubled, the respective concentrations in the first run, and the initial rate is doubled that of the first run. 1. What is the order of reaction with respect to each reactant? So Roman 1 is that because doubling of concentration of A, while that of B was kept constant, rate doubled. But when both concentrations were doubled, means for A and B, still the rate was doubled. So it shows that the reaction is a first order with respect to A, and it is a zero order with respect to B. So it shows that even if the concentration of B was doubled, still the rate of reaction was not affected. Then in Roman 2, what is the rate law for the reaction? So the rate law here is equal to K concentration of A, because the concentration of B is a concentration of B power 0. Then C. Question number 2C. The question says, if the standard cell potential for the reaction, this is a reaction, aqueous, then plus B then you get, here's a solid, you get A solid plus B, 2 positive aqueous. Now, if the standard cell potential, so the standard cell potential is equal to 0.25 volt. 0.25 volt. What will be its cell potential at room temperature if the concentration of A is 1,000 times that of concentration of B positive. Now, what will be the cell potential if the concentration of A is 1,000 times that of B? Now, let the concentration of B equal to X moles. So it means the concentration of A is equal to 1,000 X. Now from Nernst equation, that cell potential is equal to standard cell potential minus 0.0592, because this reaction took place at room temperature. Then concentration of B divided by concentration of A. Now, where N is equal to 2, so cell potential is equal to 0.25 minus 0.0592 divided by 2 log of X over 1,000 X. Then this gives us 0.16 volt. So this is the cell potential if the concentration of A is 1,000 that of B. Then question number 2D. A Form 6 student made up a galvanic cell from silver and lead half cells. She decided to use a salt bridge made from filter paper dipped in potassium chloride solution. Why was this a mistake? Now, cell potential was made from the two half cells, lead half cell and the silver half cell. Normally, the standard electrode potentials for the two, so this is lead solution aqueous, because it has lower standard electrode potential. This is the silver solution, then this is the silver electrode, this is a lead electrode. Now, if the salt, then this is the cell potential. But when if this cell was constructed in such a way that the salt bridge was used, here we have a salt bridge. Now, these are two electrolytes. If the salt bridge used here is chloride, potassium chloride, and here is lead ions, aqueous, and this is a silver ions, aqueous. This is a lead metal, and this is a silver metal. Now the question is why this is mistake to using lead 2 chloride. Now lead 2, this potassium chloride is the source of chloride ions. Now once these chloride ions move to silver half cell, so they will react chloride aqueous plus silver ions aqueous. This will form silver chloride precipitate. So now that silver chloride is a slightly soluble or insoluble in water, so it means the cell will not work because it will precipitate instead of chloride ions entering this cathode half cell and balance or maintaining the cell neutrality. Instead, or electrical neutrality, instead it will precipitate and the cell will not work. So as a result, what is needed here is that inert electrode, inert salt bridge. Inert salt bridge should be used. Salt bridge should be used. Should be used. For example, nitrates. Nitrates, we know that all nitrates are soluble in water. So we can use potassium nitrate, we can use ammonium nitrate. All these are solutions of salts which can be used as a salt bridge. So this was a mistake because chloride ions will precipitate with either silver or chloride ions. As a result, the cell will not work. The cell will not work. Now question number 3. The question is about acids, bases, and salts, as well as the solubility product. The first question is 3A Roman 1. 3A Roman 1 says, a student saw a bottle of marked acid pH is equal to 5 on the label. He said to his friend that the bottle must contain a very weak acid. Was he correct? The question is, now this student saw a bottle which was labeled. We know that in the lab normally the solutions must be labeled. Or let's say this is a label, pH is equal to 5. And it shows that this solution is acid because its pH is less than 7. Now, this student told his friend that it shows that this is a weak acid. Now, was this student correct? No, he was not correct. No, was not correct. Was not correct because we cannot know the strength of acid by looking at its pH value, because the strength of acid is quite different from the concentration. Normally pH determines the concentration, not the strength of the acid. Because when we say this is a weak acid or strong acid, we are talking about the extent of formation of free ions, that is dissociation. But when we talk of concentration, we are talking about the amount of that particular acid in a given solution. So if the solution or the acid can be weak acid or a strong acid, still it can be diluted or concentrated. And also the acid can be diluted for weak or concentrated for strong acid. So this student was not correct because this one does not indicate the strength, or does not indicate that if the acid is weak or strong. Instead, this indicates the concentration of acid. The concentration of acid. So the concentration of the pH is determined by concentration, because the acid can be strong or weak, still it can be concentrated or diluted. Then Roman 2. Roman 2 says, what are the practical applications of buffer in real life? Application of buffers in real life. In manufacture of different materials, dyes, paints, cosmetics, normally you have to consider the buffer in order to maintain the buffer. And another one is blood. Our blood are buffer solutions. They may retain the temperature change or the pH change even if the small amount of acid or base is added. So blood is a buffer solution with the pH of 7.4. So as a result, this is another application. This is another application. So this is another application of buffers in daily life. Now question number 3b. Like all equilibrium constants, the ionic product of water changes its value as the temperature changes. At 298 Kelvin, Kw is 1 times 10 power negative 14. At 338 Kelvin, its value changes to Kw is equal to 2.92 times 10 power negative 14. The question 1 is dissociation of water into ions, an endothermic or an exothermic. The answer is endothermic. That is why when it absorbs the heat, then it dissociates more. That is why its Kw value increases. For example, here at 338, it is 2.92 times 10 power negative 14, while at room temperature, which is 298 Kelvin, it is 1 times 10 power negative 14. Now Roman 2, what is the concentration of hydrogen ions at room temperature? So there is Kw is equal to hydrogen ion concentration times the hydroxide ion concentration. Now because the Kw is 1 times 10 power negative 14, so if you calculate it, then you will get hydrogen ion concentration is equal to 1 times 10 power negative 7 molar. So this is concentration of hydrogen ions at 298 Kelvin. Now what is the pH of water at 338 Kelvin? So you calculate first the Kw. Here is hydrogen ion, then hydroxide ions. This is equal to 2.92 times 10 power negative 14. Now if we calculate the hydrogen ion concentration, then you will get 1.71, then times 10 power negative 7. This will be molar. Now by calculating the pH, you will get 6.77. So it shows that it is not necessary that the pH of solution or of water must be 7. So it depends on temperature and its Kw value. Then question number 3c. C says a friend tells you the constant Ksp of a salt is called the solubility product constant, and is calculated from the concentration of ions in the solution. Thus, if salt A dissolves to a greater extent than salt B, salt A must have a high Ksp than salt B. Do you agree with your friend? Explain. Yes, I agree with my friend, because if A dissolves in a large extent, so it means it forms more free ions. As a result, we say this is, so it will have high Ksp value, Ksp value, because it will form, or it contains more free ions. So it means that there is a high concentration of free ions. That is why its Ksp value will be high. Then D, question number 3D. Question number 3D says, calculate the molar solubility of an 3 hydroxide. Ksp is 4 times 10 power negative 38 in 1 water, then 2 a solution buffered at pH is equal to 5. So this one, you have iron 3 hydroxide solid. This dissociates partially to form iron 3 ions aqueous, plus 3 hydroxide ions aqueous. Then if this is X, 3X, then the solubility in water, we take the solubility, molar solubility of iron 3 hydroxide dissolved is equal to concentration of iron 3 ions, which is equal to 3 hydroxide ion concentration. So KSP is equal to hydroxide ion concentration. This is power 3 times the iron 3 ion. So this is equal to X, so the 3X power 3 times X. This gives 27X power 4. So it's equal to KSP. So X is equal to, this will be the fourth root of KSP over 4, which will give us the value here. The answer is, if you calculate the equilibrium constant, here is the value is 4, is 1 times 10, 1 times 10 power negative 13 molar. So this is the molarity or molar solubility in water. Then molar solubility in a solution whose pH is equal to 5.0. Then this one, first you calculate the hydroxide ion concentration from the formula pH plus pOH. pOH is equal to 14. So pOH is equal to 14 minus 5, which gives us 90.0. Now from there, we calculated the hydroxide ion concentration, whereby this will give us plus, so this will give us the concentration, new concentration of hydroxide ions. Solid, this forms equilibrium, and 3 aqueous, then plus 3 hydroxide aqueous. Here is 3x plus, then when you calculate the concentration, here you will get the concentration will be 1 times 10 power negative 9. Then here is x. So by calculating the KSP, value is equal to x times 3x plus 1 times 10 power negative 9 power 3. But this one you ignore. This is x. Then 1 times 10 power negative 9 power 3. Then finally x will be equal to 4 times 10 power negative 11. This is molar. So this is the solubility of iron 3 hydroxide in a buffered solution with the pH is equal to 5. If the pH is equal to 5. Now question number 4. Question number 4. Question number 4A. Question number 4A. Now the question is about to select periodic classification of elements. Now the question is, explain the following facts. Roman 1. Roman 1. Fluorine has lower electron affinity than chlorine. This is because of its small size. Because of its small size. Small size that will make it to repel the incoming electrons in such a way that make it to possess low electron affinity. So it repels the incoming electrons in such a way that these electrons will involve low electron affinity. 2. Nitric acid can be stored and transported in aluminum containers, while concentrated sulfuric acid cannot. This is because nitric acid form or reacts with the aluminium to form a protective layer of aluminium oxide, and then this one stops the reaction. And then from there we can store and transport nitric acid by using aluminium containers at not sulfuric, because sulfuric acid reacts with the aluminium. Then Roman 3, anhydrous magnesium chloride. Anhydrous magnesium chloride cannot be prepared by heating hydrated magnesium chloride hexahydrate. This is because if you heat hydrated magnesium chloride hexahydrate, on heating it will hydrolyze with the one water molecule to form basic chloride plus 5 hydrogen chloride, plus 5 water molecules plus hydrogen chloride. So the reason is because on heating hydrated magnesium chloride hexahydrate hydrolyzes with the one water molecule to form basic salt. That is magnesium hydroxychloride instead of forming anhydrous magnesium chloride. So this is not possible because of hydrolysis that is occurs when you heat hydrated magnesium chloride. Then question number 4b. With the reasons, arrange the following structures of oxo acids of period 3 elements in order of increasing acidity. Roman 1. So these acids, Roman 1, these acids are arranged as follows. These acids are arranged as follows. They are arranged as follows. So the strongest is perchloric acid, followed by sulfuric, and finally phosphoric acid. So in the order of increasing acidic strength. So this is the range. This is the arrangement. Then perchloric acid, ClO4. Why? Because here is the acid contains a double bond, then it becomes more strong. So this one, it contains only one double bond. This one has two double bonds, but this one carries three double bonds, which makes it double bonds. Now, here we say that perchloric acid is stronger. It means it releases its hydrogen easily, followed by this one, and the final is phosphoric. So their structures determines their strength. Another one is that Roman 2, the order is chloric acid, chlorous acid, that is followed by chloric acid. This one is a Cl, then O3, and the finally is a sulfuric acid. So this is the order of arrangement. Then question number 4c. Roman 1 says aluminium is extracted by electrolysis method, while tin is not. Why aluminium is extracted by electrolysis method? So this is because aluminium is a strong reducing agent. Reducing agent that cannot be extracted by reduction method, means it cannot be extracted by using any other reducing agent to reduce it's a compound to aluminum. For example, in the extraction of iron, in the blast furnace, carbon is used as a reducing agent. But if you apply this one, for example, to extract aluminum from bauxite, so you cannot use any reducing agent because itself is a strong reducing agent as compared to copper, which is a weak reducing agent. Then Roman 2. What properties make aluminum be used in making cooking utensils and aircraft body buildings? Now, what makes aluminum to be used as in making cooking utensils? This is because aluminum is a good conductor of heat. It is a good conductor of heat. And why it is used to form aircraft body buildings or body is because it is light. It is light metal. So it is not heavy as other metals like iron. So these are the properties which make aluminum to be used as a material for making cooking utensils as well as aircraft bodies. Then question number 5. Question number 5A. Explain how the following features affect the ability of transition elements to form complexes. Explaining how the following features affects the ability of transition elements to form complexes. Normally, complexes formed between transition elements and other chemical species, which are essentially known as ligands. There are several factors, but one of these factors or features is their cationic size, as well as the presence of empty orbital. That will be available to accommodate a pair of electrons from ligands. So 1, ionic size. So here there must be small cationic size. Cationic size. So central element or the transition element ion must be very small in size. Vacant d orbitals. So vacant d orbitals. So it means this is so this one, it means this will attract. It will attract ligands or chemical species with the lone pair of electrons. Now vacant d orbitals. When we say vacant, so empty vacant d orbital. Here is there to accommodate. Here is to accommodate a pair of electrons. Pair of electrons from ligands. So these are two features which enable transition element ions to form complexes. They are small cationic size which attracts the ligands, and also vacant d orbital that can accommodate a pair of electrons from ligands. Then B. Question number 5B. Roman 1. Roman 1 says, what electronic features must a donor atom of any ligand possess? What electronic structure or feature that ligand must possess lone pair? Must possess lone pair of electrons. In order to qualify as a component of a complex. 2. What is the difference between coordination number and the oxidation number. Coordination number and the oxidation number. Now coordination number, this is the number of bonds. Number of bonds formed between a central element or transition element and the ligand. And the ligand. That is the coordination number. And the oxidation number, we say oxidation number, this is the number of electrons, an atom gain, lose or share during bond formation. So that is the oxidation number. So the coordination number is the number of bonds formed between a ligand and the central metal element, metal atom. For example, in the transition elements, the central metal element normally is a transition metal ion, and the ligands are these chemical species with the pair of electrons. They can be negatively charged or they can be neutral. But the oxidation number is the number of electrons an atom share, gain or lose during chemical reaction. That is why once the oxidation number can be determined by counting the number of electrons an atom contributing during bonding formation. Question number 5B Roman 3. 5B Roman 3, which says that a white gaseous precipitate of zinc hydroxide dissolves when excess potassium hydroxide solution is added. This is due to formation of complex. Formation of zinc complex, which is zinc hydroxide. Here is 4, then 2 minus. So this is the complex formed during this process. Then you see what makes a phenol different from alcohols, despite the fact that both have same hydroxyl group. Phenol, normally they are strong acids because of mesomerism taking place within the benzene ring, while alcohol they act as weak acids. But also phenol is the compound formed when the hydroxyl group is directly bonded to benzene ring, while the alcohol is the one is the compound that is formed when the hydroxyl group is directly bonded to the aliphatic hydrocarbon or alkyl group. So these are the differences. Then D. Saran is a polymer used to make food wrapping materials. This polymer is made by alternating chloroethene and 1,1-dichloroethane monomers. Which type of polymerization is this? So the type of polymerization is the additional polymerization. It is the additional polymerization. Then draw the structure of the respective unit of Saran. This is the structure. Here is a Roman 2. The Roman 2 is a CH2, double bond C, then a Cl. This is a Cl. Then Roman 3. Roman 3, what type of Roman 3 is what type of forces holding? The force here is a Van der Waals forces. Van der Waals forces. forces of attraction. Van der Waals forces. So these are the forces which are holding this structure. Then the last question is question number 6. Question number 6. Question number 6. Now the question says A. Draw the structures of formula of each of the following compounds. The structure of formulas of each of the following compounds will be Roman 2, Roman 1, 2, 3, and 4, up to Roman 5. Write the structure of formula of these compounds. Then in the compound Roman 1 is this one is benzoic acid, COOH. Then Roman 2, so Roman 1 here is CH, 3CO, then CH2, CO, CH3. Then Roman 2. So Roman 1 is pentane 2,4 diol. Pentane 2,4 diol. Then Roman 2 benzaldehyde. Its structure is this is its structure COH. Number 3 is ethanoic acid. Ethanoic acid, also known as the oxalic acid. So it is HOOCCOOH. Then Roman 4 is phenyl benzoate. This is C, and then O. This is phenyl benzoate. The last one is a tripropylic amine. So tripropylic amine, here is CH3, CH2, N, CH2, CH3, and this one is CH2, CH3. So this is then question number 6B. Roman 1. Give one chemical test to distinguish methyl amine and dimethyl amine. This is the method used to distinguish primary and secondary amine. So we can use nitrous acid can be used, that is H and O2, and also we can use it using Hinsberg's reagent. So this is Roman 1. Then Roman 2, the question says, explain the reason why cooks add lemons juice when they prepare fish for meal. So the answer here is because to increase the flavor, and also because lemon is acid, so the acidity of lemon juice acts through the richness of and the oiliness of fish using creating a more balanced flavor profile. So because lemon is acid, its acidity, then it destroys oil or fat, and also it increases the flavor of fish. Increases the flavor of fish. That is why the lemon. Then is C. Question number 6 is C. The question says compound M, which is commonly added to foods to give them the rum flavor, has the following structural formula. It has the following structural formula. Here is C, then double bond O, then C2, and CH3. So this is compound M. Now, Roman 1. To which class of organic compounds does the compound M belongs? So this is an ester. It is in a group of ester. That is Roman 1. Roman 1 is an ester. Then Roman 2 says, how would you synthesize a compound M from ethanol, methanol, and any other reagents. So this one compound oxidizes the methanol. So first step, oxidize methanol. If methanol is oxidized, then you will form methanoic acid, or call which is formic acid. So CH3, so this is a HCOOH. This is a methanoic acid. Then you allow this to react with the ethanol. CH3, CH2OH, then in the presence of sulfuric acid. The reaction is esterification, and finally you will get the intended product or compound M. CH2, CH3 plus water, So this reaction is known as esterification reaction. That is why we said this compound is under the class of organic compounds called the esters. Now, then Roman 3 is named the compound. The compound is ethyl methanoate. It is ethyl methanoate. And the last question or part, that is D. D, which says a carbon compound A was reduced with the lithium aluminium tetrahydride to give compound B. Compound B was dehydrated with a concentrated sulfuric acid to give one product, C. Molecular formula C5H10. Ozonolysis of C gave ethanol and another compound D with the molecular formula C3H6O. Compound D gives a positive iodoform test. Identify compounds A to D by giving their structural formulae and IUPAC names. Give the reaction equations for the above reactions. So the first part, A, this one probably is a carbon compound. Because on a reduction by using lithium aluminum hydride, which is a strong reducing agent, it gives a compound B that can be dehydrated. So it means compound B is an alcohol. Then after dehydration of B, the compound C was formed. This is a alkene. And on ozonolysis, then this alkene gives two products, the ethanol, and another one is a carbon compound with the 3 carbon atoms, 6 hydrogen atoms, and 1 oxygen. It shows that because compound D can give positive results or positive test with the iodoform test, it means it is a compound carrying a terminal methyl group. And finally, the question is, so in this reaction, so that is D, we say compounds. Now A, compound A is a CH, 3 double bond. This is CH, here's a CH3, then CH, here is a CH, CH2, yeah, then CH3. Then B, compound B is a CH, 3 CH, that is OH, then CH, here's a CH3, CH3. Then C, compound C is CH3, C double bond, C, then CH3, here's a CH3. Then compound D is CH3, this is double bond, that is a CH3. Now reactions, here is, so these are reactions which took place during these processes. The one is CH, 3, C double bond O, this is CH, here is CH3, CH3, then plus lithium, aluminium, then hydride, followed by hydrolysis. Essentially must be followed by hydrolysis. Then you'll get CH, here is CH, here is OH, C, here is CH3, here is CH, then the CH3. So this is a reaction. So this is A, this is B. The next reaction is a CH, 3 CH, OH, then C, CH3, HCH3. Then here is plus concentrated acid, sulfuric acid, then you heat, then this will dehydrate to form alcohol, to form alkene, CH, then a double bond, here is a CH3, then a CH3. So this one is compound C, this is D. And the last one is CH3, C double bond, CH3, then a plus iodine in the presence of hydroxide. Then the major product will be HC3. This is a yellow precipitate plus other products, other products. So this is the end of our discussion about paper 2, advanced chemistry, ready for preparation for for your national exams. Thank you very much. And these questions also they are found in our St. Joseph University platform, and you can get more information from there. Thank you very much, and I wish you all the best in your national examination preparation. Thank you. At a constant temperature, will remain constant unless the temperature is changed. except the equilibrium position can change. If we introduce any external factor like concentration, temperature, but if the equilibrium temperature remain constant, then the equilibrium also remain constant. And know that, or remember that, equilibrium constants or equilibrium systems are dynamic. They are not static. They are dynamic. That is why they can change their position depending on external factors like concentration change, temperature change, pressure change if the equilibrium system involves gases. So the equilibrium system is dynamic. It is never stationary. It is dynamic. That is why once you introduce any external factor, as according to the Cartesian principle, it changes its position to show that it is not stationary. It is dynamic. Now, question number 1. Question Roman 1. Roman 1 is that, does the reaction cease when the solution becomes blue? Remember I said this equilibrium system was formed by first dissolving cobalt 2 chloride crystals in water. Then the pink solution was formed. Then hydrochloric acid, which is the source of chloride ions, was added. Then the equilibrium system was established between this complex and this one. Then if this equilibrium is achieved, now the question is, does the reaction cease when the solution becomes blue? So when the solution becomes blue, it means the equilibrium has been achieved. Equilibrium point or equilibrium point has been achieved. As a result, we say the equilibrium system is dynamic, so the equilibrium will not cease. So the equilibrium will not cease. Will not cease. Why? Because the equilibrium system is dynamic. Because the equilibrium system is dynamic. It is never stationary. It is dynamic. That is one. The second question is, the forward reaction is endothermic. Explaining the color change observed on cooling the reaction mixture. Now, remember, when we consider heat or the temperature as one of the factors which can affect equilibrium position, we have to consider the type of reaction in relation to heat change. Does the reaction absorb or lose heat? Does it absorb or lose heat? Now, according to our question, the question says our reaction is endothermic. Now, for the endothermic reaction, heat is a part of reactant. For endothermic reaction, heat is a part of reactant. So it means if you add heat energy in this reaction, this will be added to the reactant side or left-hand side of the equation. And for exothermic, heat is a part of product. Now, when we say exothermic, it means heat is given out by the system, and when it is endothermic, heat is added. Now, if this reaction is endothermic, so it means heat is a part of a reactant. Now, the question is, the forward reaction is endothermic. Explain the color change observed on cooling the reaction mixture. Now, on cooling, it means you lower the temperature. If you lower the temperature, the same as removing the heat. And because the reaction is endothermic, heat is a part of reactant. So it means the same as removing or reducing the amount of reactant. Is according to Lefketelius' principle, by if we remove the amount of reactant, you will affect the position of equilibrium to shift from right hand side to left hand side. Now if we go back to our equation, if the reaction now is reversible or is reversible, so it means that if you change the position to for the equilibrium system to move from right hand side or product side to reactant side, so it means the color will change from blue to pink. So the observation here will be the pinky color. Pinky color will appear. Pinky color will appear. So the observed change is the appearance of pink color. Now the last equation or part of this equation number 8 is identify one way of reversing the change caused by cooling the reaction. As I said, if we cool the reaction and our reaction is endothermic, so it means you will favor reverse reaction, then how can we reverse or how can we change this reaction or equilibrium system to move from right hand side to or left hand side to right hand side is by adding hydrochloric acid. So this will be changed by or reversed by adding hydrochloric acid, because hydrochloric acid, which in the past the source of chloride, is a reactant. So it means if we increase the concentration or the amount of reactant as according to Lefketelius' principle, then you will favor forward reaction. You will favor forward reaction, which will be the reversing of the process or occurred during cooling. Then we go to question number 9. Question number 9. Question number 9. So question number 9 is the question number 9 is about organic chemistry. This is organic chemistry, and essentially is about hydrocarbons, aliphatic hydrocarbons, as well as haloalkanes or alkyl halides. Now question number 9a. Question number 9a says that explain the following chemical phenomena. Explaining the following chemical phenomena. Now phenomenon number 1 is that hydration of alkene like ethene is possible only in the presence of acid. Hydration, addition of water over any alkene, is possible only in the presence of acid. Why? So if we take ethene as given as an example, ethene H. Now if you add water, this is the hydration, liquid, then remember water has 2 lone pairs of O. So here there is no reaction. There is no reaction. But the question says in the absence of acid, no reaction. So it means in the presence of acid, reaction occurs. So if we take now alkene and we consider ethene as our example or representative plus water, then in the presence of acid, hydrogen ions as from acid, here reaction occurs, and the product normally is an alcohol, H, this is HH. So an alcohol forms. Why alkenes like ethane and the water do not react in the absence of acid? The reason is because both alkene and water are both nucleophiles. They are nucleophiles. And the nucleophiles, these are chemical species carrying excess electrons, carrying pair of electrons. So it means they are responsible for the donation of electrons. So here, this one, alkene and the water do not react because both are nucleophiles. So they have excess electrons. Now, in order for the two to react, is for acid which will release hydrogen as an electrophile. So this one will change alkene to an electrophile. To an electrophile that will enable it react with the water. This becomes a positive, then plus. Now here it can be attacked by lone pair of electrons, and then finally you will end up with the formation of alcohol. H, or H, and the acid will regenerate. So the reason here on why alkenes and the water do not react in the absence of acid is because both the alkene and the water are nucleophiles with the excess electrons. So in order for them to react, so one must be converted or changed to electrophile. And here what is more susceptible to reaction is the alkene. Then the pi bond will attack the hydrogen ions from acid, and they form a carbocation as an intermediate that will be attacked by water, and finally you will get an alcohol. Then Roman 2. Hydrohalogenation of buty-1-ene gives 2 products, while that of buty-2-ene gives 1 product. That is 2. That if you take this buty-1-ene plus hydrogen halide. Now, because this is a terminal and it is asymmetrical alkene, normally it gives 2 products. Because here there are 2 alternatives, as according to Markovnikov and anti-Markovnikov reactions, then 2 products will be formed. The first one, as according to Markovnikov's rule, the hydrogen from hydrogen halide, this one will attack the carbon carrying more hydrogen atoms. So the product will be CH3, CH2, CH, this is X, then the CH3. So this is your major product. Major product as according to Markovnikov's rule. Now anti-Markovnikov's is where now the hydrogen from hydrogen halide will attack the carbon carrying, let's say, hydrogen atoms. This is CH2, then the CH2, 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 then X. So 2 products are formed. But if you take buty-2-ene, this is a symmetrical alkene, normally producing 1 product. It will give only 1 product, which is a 2 halo alkyl. CH, this one can be then the CH2, CH3. So the reason here is because buty-1-ene is a asymmetrical terminal alkene, which is according to Markovnikov's rule and anti-Markovnikov's rule, 2 products will be formed. But buty-2-ene is a symmetrical alkene, which will end up with the formation of 1 product. Roman 3. The reaction between bromine water and alkene gives a vicinal dibromoalkane as a minor product, and the bromoalkanol as a major product. Roman 3. The reason why the reaction between alkene and bromine water. Bromine water which end up with the formation of 2 products. That is vicinal compound. This is a bromine. This is a bromine. This is a vicinal. This is a vicinal compound. Vicinal compound is haloalkane or dihaloalkane, where the two similar halogens are bonded to two adjacent carbon atoms. Then the second product is bromoalkane. Bromoalkane. This is bromine. Then here is OH. Now the reason here is because bromine is slightly soluble in water. Slightly soluble in water. So after dissolving, it will form few bromium and bromide ions. Bromium means a positively charged halogen, and the bromide is a negatively charged halogen. Now, the bromide ions and the water molecules are both nucleophiles. So after the bromium has reacted as the first reactant, because alkene undergo electrophilic addition reaction. So electrophile is added first, followed by nucleophile. So the electrophile here is bromium. So in both products will be the first chemical species to attack the alkene. But the second particle to attack the carbocation is either bromide ions or water molecules. Now, because bromine dissolve slightly in water, so it produces few bromide ions as compared to the amount of water molecules. As a result, there is a high probability of water molecules to react compared to bromide ions. As a result, bromoalkanol now remain as a major product. This is a bromoalkanol. So this is the answer. Then question number 9b. Question number 9b said that give three chemical distinction tests between alkanes and alkenes. Alkanes are compounds with the alkanes are hydrocarbons with a single bond, carbon single bond, while alkenes are aliphatic hydrocarbons with a carbon double bond. Now, how can we distinguish these two classes of aliphatic hydrocarbons? We can use potassium permanganate, whether an acidified or the potassium permanganate or even potassium dichromate in acidic or in basic medium. They will react with the alkene. So we say here we use potassium permanganate or potassium dichromate will be decolorized. Decolorized by alkenes. So this will react with the alkenes. But alkanes do not react. So one of the distinction tests is alkenes decolorize potassium permanganate or potassium dichromate, because potassium permanganate is purple in color, while potassium dichromate is orange in color. So they can be decolorized by alkenes. Then another test is that alkenes can decolorize bromine water. Decolorize bromine water. Bromine water is brown in color. Now, as we have seen here, we say that bromine water reacts with the alkene. So this is a brown in color, then the two products formed are colorless. So this is another method that can be used to distinguish alkenes and alkanes. So alkanes do not react with the bromine water, but alkenes react with the bromine water, and the bromine water will be decolorized due to formation of vinyl haloalkane as well as a bromo alkano. Another one is we can use sulfuric acid. That is alkenes precipitates with the sulfuric acid. So alkenes can react with the sulfuric acid to form white precipitate, while alkanes do not react. So these are the distinctive methods or tests which can be used to distinguish between alkanes and alkenes. Question number 9C. Give products that will be obtained when 2-bromobutane reacts with each of the following. Bromobutane, 2-bromobutane reacts. That is C. Bromo C3CH. This is a Br. CH2CH3 plus. Now, one is aqueous potassium hydroxide, aqueous. So this one will end up with the formation of alcohol, CH3, CH, then OH, CH3, CH2, CH3. Now, this is the potassium bromide. So this is a nucleophilic substitution reaction. Then if now 2-bromobutane, CH3, CH, then Br is allowed to react with the potassium hydroxide solution in the presence of alcohol. Then here what happens is a elimination reaction. As a result, two products will be formed, CH2, CH3, or CH3, CH, double bond CH2, CH3. So this is a major product. Major product. So though we have the same reactants, but the only difference that causes this reactant or reactions to end up with the different products is conditions. Here is CH3, then this is R. Now, the reason is what? The reason is because nitro group, this is a deactivator. So it is a meta director. And in benzene ring, substituted benzene ring, we have only one meta position. So only one product will be formed. But methyl group is an activator. It is an activator, so it is the ortho para director. So it will form two products. That is ortho product and then para product. That is why the alkylation of nitrobenzene end up with the formation of one product, because the nitro group is a deactivator, which in turn is a meta director, while the alkylation of toluene or methyl benzene end up with the formation of two products, because methyl group is an activator, which is an ortho para director. So the two products will be ortho as well as the para products. Then Roman 2. Roman 2 says sulfonation of phenol is faster than the sulfonation of benzoic acid. Give reason. Sulfonation, this is the reaction between benzene ring and sulfuric acid to form sulfonic acid. Benzene sulfonic acid. Now the question is sulfonation of phenol is faster than that. This question is a C. Question number 10 is C. Question number 10 is C. Question number 10 is C. Says outline the synthetic pathways and write balanced chemical equations to show how to prepare methyl benzene and the benzoic acid separately using benzene as the starting material. Specify the reagents, catalysts, conditions of the reactions, and any intermediate steps that are used in each synthesis. Now here, remember that the starting material here is benzene. Benzene is the starting material. Now the question is to show on how to prepare methyl benzene and also benzoic acid. Benzene and benzoic acid. Now methyl benzene is the reaction that can be obtained by the reaction between benzene and methyl halide. Benzene and the methyl halide in the presence of Lewis acid. So we take methyl halide in the presence of aluminum halide, then we get methyl benzene or toluene, CH3 plus hydrogen halide. Now, if this halogen is a chlorine, here also must be chlorine. If this is a bromine, this also must be bromine. If this is iodine, as well as this one. So this is the pathway for the synthesis of methyl benzene. So the starting material is benzene. Another reactant is methyl halide, and the condition is in the presence of aluminum halide as Lewis acid. And this is a catalyst, is the one which plays a big role in a reaction or in the reaction or alkylation of benzene ring. Then the second one is a formation of benzoic acid, but the starting material must be benzene ring. So the first one is alkylation of benzene to form alkyl halide. So here we have Lewis acid, aluminum halide, then we'll get this is a alkyl benzene. Then in this one, then what next is the oxidation. We can use potassium permanganate or potassium dichromate, any oxidizing agent that is a strong oxidizing agent in acidic medium, then you heat. So we use an oxidizing agent. Now, whenever you find the oxygen atom enclosed in a square bracket, it indicates that This oxygen is derived from oxidizing agent. So in the presence of acid, here is the sulfuric acid, then heat, so you get carboxylic acid or benzoic acid. Now, benzoic acid is formed when the oxidizing agent is used to oxidize any alkyl benzene, regardless of the size of alkyl group, because in our case R represents the alkyl group. It can be the alkyl group of any size. It can be with 1 carbon atom, 2 carbon atoms, 5 carbon atoms, but when this is oxidized by using oxidizing agent like potassium permanganate, then the end product will be benzoic acid and the other products. Products. So this is the end of the presentation of the paper 1 in advanced level chemistry, as according to our national examination format. I think we have got the many things to revise or to prepare you ready for the national examination, which is just around the corner. And I'm sure that according to this presentation, you will make it, or you will be very smart in your examination. And for more information, the questions and also the answers also can be obtained from our St. Joseph University platform. Thank you very much. Then welcome for the next paper, that is chemistry paper 2, after a few minutes. Thank you very much. Thank you very much. Welcome to chemistry 2, advanced level chemistry, preparation for Form 6 examinations 2025. Of iodine is CH3, then this is R. Now the reason is what? The reason is because nitro group, this is a deactivator. So it is a meta director. And in benzene ring, substituted benzene ring, we have only one meta position. So only one product will be formed. But methyl group is an activator. It is an activator, so it is the ortho para director. So it will form two products. That is ortho product and then para product. That is why the alkylation of nitrobenzene end up with the formation of one product, because the nitro group is a deactivator, which in turn is a meta director, while the alkylation of toluene or methyl benzene end up with the formation of two products, because methyl group is an activator, which is an ortho para director. So the two products will be ortho as well as the para products. Then Roman 2. Roman 2 says sulfonation of phenol is faster than the sulfonation of benzoic acid. Give reason. Sulfonation, this is the reaction between benzene ring and sulfuric acid to form sulfonic acid. Benzene sulfonic acid. Now the question is sulfonation of the sulfonation of phenol is faster than that. This question is a C. C. Question number 10 is C. Question number 10 is C. Question number 10 is C. Says outline the synthetic pathways and write balanced chemical equations to show how to prepare methyl benzene and the benzoic acid separately using benzene as the starting material. Specify the reagents, catalysts, conditions of the reactions, and any intermediate steps that are used in each synthesis. Now here, remember that the starting material here is benzene. Benzene is the starting material. Now the question is to show on how to prepare methyl benzene and also benzoic acid. Benzene and benzoic acid. Now methyl benzene is the reaction that can be obtained by the reaction between benzene and methyl halide. Benzene and the methyl halide in the presence of Lewis acid. So we take methyl halide in the presence of aluminum halide, then we get methyl benzene, or toluene, CH3 plus hydrogen halide. Now, if this halogen is a chlorine, here also must be chlorine. If this is a bromine, this also must be bromine. If this is iodine, as well as this one. So this is the pathway for the synthesis of methyl benzene. So the starting material is benzene. Another reactant is methyl halide, and the condition is in the presence of aluminum halide as Lewis acid. And this is a catalyst, is the one which plays a big role in a reaction or in the reaction or alkylation of benzene ring. Then the second one is the formation of benzoic acid, but the starting material must be benzene ring. So the first one is alkylation of benzene to form alkyl halide. So here we have Lewis acid, aluminum halide, then we'll get this is a alkyl benzene. Then in this one, then what next is the oxidation. We can use potassium permanganate or potassium dichromate, any oxidizing agent that is a strong oxidizing agent in acidic medium, then you heat. So we use an oxidizing agent. Now, whenever you find the oxygen atom enclosed in a square bracket, it indicates that this oxygen is derived from oxidizing agent. So in the presence of acid, here is the sulfuric acid, then heat, so you'll get carboxylic acid or benzoic acid. Now, benzoic acid is formed when the oxidizing agent is used to oxidize any alkyl benzene, regardless of the size of alkyl group, because in our case R represents the alkyl group. It can be the alkyl group of any size. It can be with 1 carbon atom, 2 carbon atoms, 5 carbon atoms, but when this is oxidized by using oxidizing agent like potassium permanganate, then the end product will be benzoic acid and the other products. Products. So this is the end of the presentation of the paper 1 in advanced level chemistry, as according to our national examination format. I think we have got the many things to revise or to prepare you ready for the national examination, which is just around the corner. And I'm sure that according to this presentation, you will make it, or you will be very smart in your examination. And for more information, the questions and also the answers also can be obtained from our St. Joseph University platform. Thank you very much. Then welcome for the next paper, that is chemistry paper 2, after a few minutes. Thank you very much. Thank you very much. Welcome.